Hi, this is King of Review. Here we're told that 2 to the k is greater than k squared for some k greater than or equal to 5, and we're asked to use that to prove if 2 to the k plus 1 is also greater than k plus 1 squared, so essentially plugging in k plus 1 everywhere we have k in the initial equation. Well, let's start with that initial equation, or inequality, I should say. We know that 2 to the k is greater than k squared. We're trying to prove something about 2 to the k plus 1. In general, if I have x to some power a times x to some power b, that's the same thing as x to the a plus b. So if I want 2 to the k plus 1, I can multiply this by 2 to the first power. But to keep the inequality balanced, I'm going to multiply the right side by 2 as well. The left side becomes 2 to the k plus 1, and the right side is 2k squared. So now we know 2 to the k plus 1 is greater than 2k squared, so let's try to compare 2k squared to k plus 1 squared. Well, a nice easy way to compare two numbers is to subtract them and see if you get a positive number or a negative number to see which one is bigger. So let's do 2k squared minus k plus 1 squared. If we expand k plus 1 squared, that's k plus 1 times k plus 1. And if we distribute that out, it becomes 2k squared plus 1 times k is k times 1 is k, and k plus k is 2k, and then 1 times 1 is 1. So if we subtract all these terms, we get k squared minus 2k minus 1. Now I know that the lowest k can be is 5. K is at least 5. So if I plug in 5 for k, that gives me 5 squared minus 2 times 5 minus 1, which is 25 minus 10 minus 1, which is 14. 14 is positive. It's greater than 0, meaning the lowest that k can ever be still gives us a positive number. So no matter what k is, this result, 2k squared minus k plus 1 squared, will always be greater than 0, which tells us that 2k squared is greater than k plus 1 squared. If I fill this inequality into my original inequality, I can add k plus 1 squared to the end. So now we know 2 to the k plus 1 is greater than 2k squared, which in turn is greater than k plus 1 squared. That implies that 2 to the k plus 1 will be greater than k plus 1 squared. That's the inequality we were asked to prove, and we just proved that it is true. Thanks for watching.